Good evening, everyone. So, let's start the session. I'm a engineer Shahid Mustali, chairman of Computer Engineering Sectional Committee of Institute of Engineers, Sri Lanka. So, without taking much of your time, let me introduce our speaker. Dr. Anuradha Velivata is a postdoctoral research specializing in intersection of human-computer interaction and artificial intelligence. She obtained her PhD in computer science from EPFL, Switzerland, and is a graduate of the Department of Computer Science and Engineering, University of Moratuwa. Her doctoral thesis, Empathetic Conversational Agents for Distress Support, which explores various facets of AI, including empathetic response generation and chatbot applications in distress support, was nominated for EPFL's doctoral awards. Anuradha embodies a passion for understanding the intricate relationship between humans and technology, aiming to create a empathetic and user-centric AI solution. So today's topic is building a better empathetic conversational agent for distress support. So, Dr. Anuradha, over to you.
Okay, so thank you for the kind introduction. So I hope everyone hears me well. And yeah, okay. So without further ado, let's begin the presentation. So my presentation will be centered on the topic of building a better empathetic conversational agent for distress support. And in this, I would like to share some of my research work that was conducted when I was doing my PhD at the HCI group at EPFL. Okay, so before diving into details, I would like to point towards some very important statistics. 1 of 8 people in the world live with a mental health disorder. That is around 970 million people worldwide. And suicide has now become the 4th leading cause of death among youngsters. Depression over the past 5 years has risen by an amount of 20%, making it the leading cause of disability worldwide. In the United States itself, there is an estimated 30% of people who have suffered from anxiety at least once in their lifetime. And in Sri Lanka, there are on average 40,000 plus hospital admissions per year because of mental health disorders. So all these statistics points to increased levels of psychological distress among people. The overwhelming demands that we have in today's world seem to aggravate this condition. Also, the limited availability of mental health professionals, the ever-increasing costs for mental health help, and the social stigma further seem to create barriers when people try to seek out help. So this support gap demands innovative solutions. We see a lot of potential in artificial conversational agents, also known as chatbots, to provide an efficient solution to this problem. The recent advancements in large language models, as you know, ChatGPT, Gemini, and Llama, them being available 24/7, and their ability to maintain the anonymity of users further support this idea. Speaking about conversational agents, there are mainly 2 types: task-oriented and open domain. Task-oriented agents, they mainly help users to achieve a specific goal, such as delivering an item or reserving a restaurant. In contrast, open domain conversational agents or chatbots are designed to engage in social chit-chat. They mainly focus on giving the user entertainment and companionship. Our focus here are on these open domain conversational agents or chatbots and tuning them to provide emotional support to users who are in need. So a primary trait that such a chatbot should have is the ability to empathize with the user. Empathy, we can define it as the ability to understand or feel what another person is experiencing by placing oneself in his or her situation. It's actually a multifaceted construct encompassing 3 dimensions. First is cognitive empathy, which is the ability to rationally understand a person's feelings and thoughts. Second is affective empathy, which is the ability to experience the feelings of other people. And third is compassionate empathy, which is the need to react and provide help in any way that you can. So modeling empathy in AI-powered conversational agents, we call it as empathetic conversation modeling. It mainly consists of two steps: understanding the user's emotion and responding back appropriately. So this may sound simple, but this task is particularly challenging because the agent needs to understand and differentiate between subtle variations of human emotions. So as you can see from this example, emotions sad and disappointed, even though they are situated quite close to each other in the negative spectrum of emotions, the way the chatbot seem to perceive and respond to these emotions are quite different. So when it comes to recognizing users' emotion, there are multiple different emotion models that were proposed in the past. Two of the most popular emotion models are the Paul Ekman 6 basic emotions and the Plutchik's emotion wheel. But such existing emotion models seem to classify human emotions at a very coarse-grained level. So this might not be enough for a chatbot when interpreting the emotions of a user's input. And we can divide the already existing work on empathetic chatbots mainly into two. On the left, you can see empathetic chatbots trained in an end-to-end fashion. By end-to-end, I mean these models are usually trained to converse in an empathetic way by fine-tuning on smaller data sets containing empathetic dialogues. But they have certain limitations. Because of the black box nature of these models, they often lack controllability and interpretability. And because of this, it is often difficult to rely on these models. So as a remedy, some other work, which you can see on the right, use simple rules or heuristics to guide the empathetic response generation process. They usually include conditioning the response on a predefined or similar emotion to that of the dialogue history, or using emotion-based objective functions. However, there's a problem of modeling empathy using such simple rules or heuristics, because empathy, as we saw earlier, is more multifaceted and is a lot more than mere mimicry of emotion. Also, we observe that most of these approaches are limited to understanding and responding to coarse-grained emotions, such as the Ekman 6 basic emotions, which is also a major limitation in existing empathetic chatbots. And when considering distress support, we see there are commercially available support chatbots such as Visa, Woobot, and Elomia. However, we see very limited research efforts in this area. One of the main reasons we see behind this is the lack of data sets containing dialogues providing distress support. There are some therapeutic data sets that are used for certain analysis, but they are unavailable publicly because of privacy and ethical reasons. And as a result, many researchers like us, we tend to resort to dialogue data that are scraped from online support forums such as Reddit. But the responses that we see in these data sets are unprofessional because they come from people like us who are not really trained in the practice of mental health. And because of that, this data comes with a risk. So having seen the limitations of existing work, we established some research aims to work on. The first is to build empathetic conversational agents that can understand and respond to a wide range of nuanced human emotions and provide emotional support to users undergoing psychological distress. The second is to develop resources and methods that can enable these chatbot models to be more interpretable, reliable, and sound more professional. So in order to achieve this target, we set up several research questions in line. The first is understanding what communication strategies that humans use to empathize with others. So in order to answer this question, we chose to analyze the empathetic dialogues dataset which is a collection of approximately 25,000 open domain human-to-human conversations. And these dialogues are based on situations that are grounded on one of 32 positive as well as negative emotions. And here you can see the list of emotions. And these emotions are selected from existing emotion models such as the Ekmans and the Plitviks, but at the same time incorporating more subtle emotions derived from contextual situations, which are more desirable in our case. So in the analysis process, first we chose a subset of dialogues from this dataset and qualitatively coded each of the listener utterances present in these dialogues with a label that best described their intent. By doing so, we were able to come up with a taxonomy of 15 empathetic response intents. So this list include questioning, acknowledging, agreeing, consoling, encouraging, sympathizing, wishing, suggesting, sharing own thoughts or opinion, sharing or relating to own experience, advising, expressing care or concern, expressing relief, disapproving, and appreciating. You can also see the frequencies of those intents along with some examples corresponding to these intents. Next, we searched through the rest of the dataset using words and phrases that were most indicative of these intent categories. For example, the responses corresponding to the intent agree, they mostly contained words and phrases such as absolutely, I agree, me too, I completely understand, etc. And using this, we extended these labels to approximately 7,000 more listener utterances. Next, using these labels as well as situation descriptions from the empathetic dialogues dataset, we trained a classifier that could identify 32 emotions, the 8 most frequent empathetic intents from our taxonomy, as well as the neutral category. We use this classifier to label all the utterances in the empathetic dialogues dataset, and we visualized the most frequent emotion and intent exchange patterns that we could see among these human-to-human empathetic exchanges. So according to the visualization that we could obtain, questioning and acknowledging, these two intents played a very significant role in empathetic responses, irrespective of the speaker's emotion. And intents such as sympathizing and consoling, they were frequently seen to associate with negative speaker emotions. And expressions of sympathy, they seem to immediately follow negatively intense emotions such as sad and devastated. And towards the end of the dialogues, we could see more expressions of acknowledgement as well as agreement. So overall, this serves as proof that instead of conveying a particular positive or negative emotions, humans tend to show their empathy through specific means that can be described by the intents in our taxonomy. So these intents from our taxonomy, we can readily utilize them to guide the empathetic response generation process in chatbots. Next, to further validate our taxonomy and to develop empathetic chatbot models on top of that, we wanted to curate a much larger data set conveying a variety of different emotional situations. This brought us to our second research question, that is how to curate large-scale dialogue data annotated with fine-grained emotions and empathetic communication strategies. So there are some already existing dialogue datasets, but mainly because of the cost of manual labor, these datasets are very limited in size and do not cover a wide range of emotional circumstances. Also, most of these datasets contain only a limited set of emotions that are labeled. So because of these reasons, we find these existing datasets to be quite insufficient to train such chatbots. And because curating and annotating such gold standard data is very expensive, We looked at replacing this data with automatically annotated data, which we call silver standard data. Motivated by this concept of silver standard data, we next developed the emotional dialogues in open subtitles, or the EDOS dataset, by utilizing movie and TV subtitles that we could find in this corpus called open subtitles. So why did we use movie subtitles? One reason is that they are available publicly in abundance, and they are also used extensively in emotion analysis in text in earlier as well as in recent research. The process of curating the data set involved several different stages. So in the first stage, we curated dialogues from open subtitles by applying turn and dialogue level segmentation, because the data in this corpus actually looked like this, without any explicit dialogue turns or any indication or any indicators where one dialogue ends and the other dialogue begins. And this resulted in close to 4 million dialogues. Then we applied the classifier that we developed previously to label utterances in OS dialogues, and we filtered out 1 million emotional dialogues based on the confidence scores that were generated by the classifier that we applied. We call this the initial dataset, we call it EDOS initial. And in the final stage, we first conducted a human labeling experiment in order to develop a set of gold labels from the EDOS initial dataset. This we call the seed set. And using this seed set, along with by applying data augmentation techniques, we trained a dialogue, emotion, and intent classifier. So the training of this classifier followed a semi-supervised learning approach, which I will not go much into the details. Our final classifier, developed in this manner, consists of a Roberta-based encoder. Roberta is actually a language model that was introduced in 2020 by researchers at Meta. And as input, we feed in all of the dialogue history, but incorporate a half-decaying weighting scheme to give more importance to the most recent utterances from the dialogue history. And the final classifier, which sort of underwent several learning iterations, achieved an accuracy that is close to 65%, which is comparable with the state-of-the-art dialogue emotion classifiers. So we use the final classifier to annotate the rest of the dialogue turns in EDOS initial, giving us the final 1 million emotion and intent annotated EDOS dataset. When we compare this dataset with other existing ones, the dataset we developed is significantly larger in size and consists of more fine-grained emotions as well as empathetic response strategies. So given that we now have a larger data set annotated with fine-grained emotions and empathetic response strategies, it raised us the third research question. That is, how can we train empathetic conversational agents such that they can generate empathetic responses in a more controllable and interpretable manner? So why is this important? For example, when we input the dialogue context into 3 different chatbot models, we could see that those that incorporate end-to-end response generation without any control can sometimes generate responses that can be repetitive or even suboptimal. In contrast, if we can have the response conditioned on a suitable empathetic intent, it has the ability to steer the model or guide the model to generate responses that are a bit more diverse and empathetically appropriate. So with this respect, we designed a controllable and interpretable empathetic response generation architecture, which consists of 2 modules, a response emotion or intent prediction module and a response generation module. So in this, first, the response emotion or intent predictor, it takes in the flow of emotions and intents and all the dialogue history and predicts the emotion or intent of the next response that is to be generated. So this predicted emotion or intent is fed into the decoder of the response generation model, which generates a response conditioned on the predicted emotion or intent. So we first developed a decision tree based predictor. The probabilities that you can see here along the paths are learned from the training data itself by traversing through dialogues using a window of size k. And during inference, it determines the next emotion or intent by traversing along a path in the decision tree. So we actually used two methods to determine the next emotion or intent. The first is the argmax method that sort of pick the emotion or intent with the highest probability in a given path. And the second is probabilistic sampling that randomly sampled an emotion or intent based on the distribution of probabilities of emotions and intents in a given path. We also developed a neural response intent predictor that utilizes the Roberta encoder. And unlike the decision tree based approach, in addition to the flow of emotions and intents, this model could make use of the semantic clues from the previous utterances from the dialogue history as well. And I really wouldn't go into the details of the evaluation, but what we could see is that the neural predictor sort of seemed to outperform the rest when predicting the next emotion or intent. And for generation, we also tried conditioning the response with the ground truth emotion or intent. And we saw that it performed the best across most metrics used for dialogue response evaluation. So what this shows is that if we have a very good mechanism to predict the emotion or intent of the next response, whose accuracy is very much close to the ground truth, then it can give us the best results. We also asked human workers to rate responses given by each of the models as good, okay, and bad, according to how empathetically appropriate these responses were. And we saw that the model that incorporated the neural predictor with the highest prediction accuracy, it generated the most number of good responses. And we also manually inspected the responses generated by these models, and it confirmed that having no or less effective control mechanism can lead models to generate responses that seem to be empathetically less appropriate, whereas having some good mechanism to control the responses could generate better responses in terms of empathetic quality. So, so far we talked about day-to-day casual conversations that involve positive and negative emotions. And so far the control mechanisms that we introduce seem to work well when responding to these situations. But when it comes to situations that can involve extreme negative emotions or psychological distress in particular, this type of conversations, they require special kind of responses that should be tailored towards specifically addressing such distressful situations. For example, these responses need to be much more informative as well as targeted. At the same time, be much more reliable than casual talk. And this brought us to our fourth research question, that is, how to generate reliable and topically specific responses when responding to psychological distress. So towards this end, we could observe that there is a growing interest to use knowledge graphs to generate appropriate and informative responses to conversations. However, there are certain limitations associated with existing knowledge graphs. They are mostly open domain and do not capture norms of empathetic exchanges in human conversations. There is also a lack of such resources to help us in distress management and empathetic response generation. So we saw the need to actually create such a knowledge graph. However, to develop a knowledge graph, we needed to have a lot of data, which sort of encouraged us to develop the Reddit emotional distress, or we call the RED data set. And to build this, we curated distress-related dialogues from carefully selected 8 subreddits from Reddit. Reddit, I think many of you might know, is a very popular online peer support platform. And mainly because of the anonymity in this platform, many users, they choose to vent their distress and seek advice and support from other peers when they're facing difficult times. And the dialogues we scraped from this platform, these sort of underwent a series of pre-processing steps, including the removal of profane or toxic listener utterances, which resulted in close to 1.3 million conversations. Next, we analyzed these dialogues and developed HEAL, which is a knowledge graph that represent different types of stressors, speakers' expectations or questions that they have, the responses that are commonly used to respond to these matters, and the positive or the negative feedback associated with these responses. We also tag each of these nodes with different emotional states and empathetic intents. So in order to develop this knowledge graph, we used mainly clustering and topic modeling of distress-related dialogue prompts from the RED dataset, questions asked by speakers in these dialogues, listeners' responses to them, as well as the speakers' feedback received for these responses. For example, here you can see some of the common stressors and the keywords that are associated with them, which we could discover by applying these methods. And similarly, we were able to identify clusters of speakers' expectations, common responses, as well as feedback. And here you can see a visualization of part of the final graph that we generated. It actually contains close to 22,000 nodes in total and approximately 104,000 connections in between different types of nodes. And the stressor node you can see here is representative of narratives containing suicidal thoughts. And you can see the most common expectations of a person with suicidal thoughts are, what do I do about it? Does anyone else feel this way? And what are the methods available to kill oneself? The most common responses a listener would give in this type of situation, we could see sympathetic responses such as, I'm sorry you feel like this, consoling responses such as you are not alone, and meaningful questions such as what makes you feel this way. And these responses are connected to positive feedback from the speaker. For example, thanks for the reply, which seem to show gratitude to the listener and at the same time validating that it is a good response. And by the dashed purple edges, we could see connections between common speakers' questions and listeners' responses. For example, I feel the same way is connected to does anyone else feel this way? And responses such as hang in there, my friend, and are you seeing a doctor or a therapist are connected to what do I do about it? And next, using the knowledge graph HEAL, we developed a retrieval-based model that can sort of retrieve appropriate responses from the knowledge graph given a distress-related dialogue prompt. So when it encounters a distress prompt, it first compute the cosine similarity between the new prompt and the existing prompts belonging to separate clusters, and associate the new prompt with the cluster of the existing prompt with the most similarity. And next, it would rank the responses connected with that particular stressor, first by using the edge weights and then using the cluster sizes of these responses. So by this way, HEAL is able to retrieve the most frequently used responses associated with a particular stressor and then rank them by the overall popularity of the responses. And we conducted automatic and human evaluation of responses retrieved by HEAL. against Mead and Blender, which are two of the state-of-the-art empathetic chatbot models. And we could see that responses retrieved by Heal were more diverse and were more preferred by the human workers. And in this particular case study, you can see that for two completely different situations, both Mead and Blender produce the same type of response, whereas the responses that are retrieved by Heal are much more targeted and more specific to the topic. And here for a dialog prompt stating maybe tomorrow I should just jump in front of a train, the responses of Mead as well as Blender seem very toxic and do not prevent the user from doing so. But the response that is retrieved by Heal seem more appropriate. It's the same with the second example as well, where the user talks about writing a suicide note. And here also, the response retrieved by Heal is much more appropriate than the responses given by Mead and Blender. But there are actually several limitations even to this approach. Mainly, the responses that build up this knowledge graph, they come from peers, and peers are not professionals. Because of that, we do not know how close these responses are to responses coming from professionals and whether or not they conform to established norms in psychotherapy. So this sort of brought us to our fifth research question. That is, what are the differences between responses given by peers and trained professionals for addressing distress? In order to answer this question, we looked at motivational interviewing, which is an empathy-driven approach used in counseling to influence people towards positive changes in their behavior. It is sort of used to address a variety of different situations, such as depression, anxiety, and substance use. So the main reason for looking at this is that it has an associated coding scheme called the Motivational Interviewing Treatment Integrity, or the MITI code, which is used to evaluate how well a mental health provider responds. And specific response types from the MITI code, such as questions, reflections, giving information, advice with permission, affirm, emphasize autonomy, and support. These seem to have shown to increase the likelihood of positive health outcomes when they're used in conversation. Whereas some other response types, such as advice without permission, confront, direct, and warn, these responses seem to have shown to associate with negative health outcomes. And this code is especially useful for us because it explicitly distinguishes between MI adherent and non-adherent response types. And apart from those labels, we also included this label called self-disclose, which is actually not a part of the MITI, but we included this mainly because in conversations involving peer support, self-disclosure, like disclosing things about oneself, seem to occur quite frequently. So we use this coding system and comparatively choose to analyze the differences between responses from professional counselors and peers. For dialogues between emotionally distressed people and counselors, we used a subset of 1,000 dialogues that were scraped from this counsel chat website. In this website, professional counselors, they provide answers to distress-related questions that are posted by users. And for dialogues between distressed people and peers, we used a subset of 1,000 dialogues scraped from the obtained from the RED dataset. And we recruited professional counselors from this crowdsourcing platform called Upwork in order to get them to annotate the responses in dialogues with labels adapted from the MITI code. And this resulted in the MI dataset that we used for comparative analysis. We conducted this annotation process mainly in 3 stages. In the first stage, we asked two professional workers to annotate each of the responses with MITI codes. In the second stage, we asked workers who seem to have performed very well in the previous stage to act as judges to resolve the labels that were not agreed upon by the workers in the first stage. And in the third stage, we removed the noisy labels that were given by workers with very bad performance and asked the judges to resolve the still remaining but conflicting labels. So by doing so, you can see the agreement between the workers on the labels increased over the three different stages. Then, using these annotations, we compared dialogues from council chat and red data sets. And we observed quite some significant differences between the responses coming from peers and professionals. Some of these observations were actually quite good when considering peers' responses. For example, affirmations as well as supportive responses were seen to be quite higher among peers when compared to those of counselors. But some of the observations were not quite as favorable. For example, giving information type of responses were seen to decrease by 67% in red compared to council chat. So this observation was not quite surprising because peers are comparatively less knowledgeable than professionals. And there was also close to 600% increase in self-disclosing type of responses among peers' responses compared to those from counselors. So this can also be considered unfavorable because then the focus of the conversation becomes on themselves rather than the person who is going through the distressful situation. And one of our main observations in this was that when considering MI non-adherent behavior codes, we saw that advice without permission was the most prominent MI non-adherent response type that was seen in both peers and counselors' responses. And this accounted to more than 50% of the MI non-adherent responses that were seen among both peers and counselors. So having seen such non-adherencies with established therapeutic norms, it paved the way for our next research question, which is when dialogue agents are trained on such peer support data, how can we make the responses of these chatbots sound more professional and adherent to therapeutic norms? So in order to cater to this, we introduced a two-step process. First, we introduced a classifier that can recognize MI adherent and non-adherent responses, and then a rephraser that can rephrase responses classified as advice without permission, which, as you saw, is the most prominent MI non-adherent response type that was seen in peer support dialogues. So we turned this advice without permission response type into advice with permission. In our methodology, we first use data augmentation to expand the labels in the MI dataset and use this gold and the augmented labels to train a classifier that can identify MI adherent and non-adherent response types. And this classifier was able to achieve an accuracy which is close to 74% on the MI test set. And in the next stage, we developed the MI rephraser. In order to train this rephraser, just because we did not have a data set containing corresponding pairs of advice with and without permission sentences, we resort into developing a pseudo-parallel data set with pairs of advice without and without permission responses that correspond to each other. So we used two methods to develop this pseudo-parallel corpus. First is template-based replacement. Here, by analyzing the most frequently used words and phrases, and also by manually inspecting subsets of responses from each type, we discovered a number of linguistic templates that can represent advice with permission and without permission type of responses. And if we detected such a template among advice without permission responses, we replaced it with a randomly picked template that was indicative of advice with permission. And the second method we used was a similarity-based retrieval. In this, for a given advice without permission response, we retrieved a corresponding advice with permission response whose cosine similarity was above a threshold of 0.7. And we applied these methods on both MI gold and augmented datasets, which resulted in the pseudo-parallel and pseudo-parallel augmented corpora. So we use this type of corpora to fine-tune BlenderBot and GPT-3, which are two state-of-the-art language models, and we try to make them act as an MI rephrase. So in addition to solely using this corpora, we also experimented with two types of prompting techniques. One is generic prompting, where we appended the label advice with permission to the end of the input text. And the second is n-gram-based prompting, where we appended the linguistic template indicative of advice with permission. If such a template was present in the output, we sort of fed the model with. And the final outcome of our framework is that both the MI classifier as well as the MI rephraser, these two can work together to enhance the chatbot responses with the MI strategy. And here we can, you can see we have set up a demo in order to demonstrate this. And in this demo, you can interact with two famous chatbot models, ChatGPT, which is based on GPT 3.5 and Blender. And we interacted with these models and saw that the responses given by them in support of distress, these responses still seem to consist of these MI non-adherent type of responses. And here you can see some examples of how our framework can identify such MI non-adherent paths present among these responses and boost the overall response into a more MI adherent form, which aligns with the norms from psychotherapy. And finally, I would sort of like to recap the different methods and resources that we introduced in this presentation. First, we developed a taxonomy of empathetic response intents that can be used to respond to both positive and negative emotions, followed by the EDOS dataset and a dialogue level emotion and intent classifier. And we used these resources and developed a framework for controllable and interpretable empathetic response generation. And next, we narrowed our attention towards extreme negative emotions and psychological distress, developing the RED dataset and the HEAL knowledge graph, and towards making distress support responses more professional, we introduced the MI dataset, followed by an MI classifier and an MI rephraser that sort of seem to work together to form a framework to boost distress support dialogue responses with the motivational interviewing strategy. And I would also like to point out some future directions in the area of empathetic conversational agents that we can focus our attention to. First is prompt-based empathetic response generation, where we can explore effective prompt designs that can navigate the empathetic capabilities of LLMs, such as ChatGPT, Gemini, and Llama, and learn ways how we can instruct them to carry out supportive and engaging empathetic conversations with users. And next is in the area of fairness and debiasing, where we can introduce some standardized methods to ensure the same level of support and empathy towards all users, regardless of their demographic characteristics, such as gender, age, race, or socioeconomic status. And third is in the area of cultural sensitivity, where we can study the intercultural differences of expressing emotions and empathy, and incorporate cultural understanding of empathy into the design of chatbot models. And finally, in the area of privacy and safety, where we can design and develop methodologies that can cater to the privacy and safety concerns that are associated with empathetic conversational agents. And speaking about applications of empathetic agents, these are not limited to providing support during distress, but they can sort of span across a lot of other domains as well. For example, conversational agents using the motivational interviewing strategy can be deployed as motivational coaches, since motivational interviewing can be applied in settings such as substance use, behavior addiction, and procrastination. And these agents can be used as empathetic customer support agents and also as social companions for elderly people suffering from loneliness. And finally, I would like to point your attention to a list of publications that I based my presentation on. And if you're interested, you can refer to these publications, and especially if you need more technical details about the things that we implemented. And lastly, I would like to acknowledge my research supervisor, Dr. Pearl Poo, and my colleagues, Dr. Yubo Shea, Dr. Katerina Swiknushina, and engineer Chung Hunge for collaborating me on these various research topics. And I would also like to thank Professor Chandana Gamage for providing me this opportunity to share my research and insights with you all. So thank you so much for listening. And now I would like to open the floor for any questions if you have. Thank you.
Thank you, Dr. Anuradha. Any questions? Hope you can unmute the mic. Or you can type your question in the chat box. Any questions?
Dr. Anuradha, I have a question.
Yes, Professor Gama.
Yeah, the models, are they able to support across age ranges?
Right now, we actually did not differentiate between like young people, elderly people, middle-aged people. So right now, these models do have a limitation in like addressing concerns of people from different age groups, as well as people from different cultures. So I think, yes, as future work, I think it is also a very good direction that we can focus our attention to, like, how can we support people going through distressful situations, like if the elderly ones, like if they're small children or people who are teenagers and young people. So yes, I think it's a very good direction that we can point our attention to.
That's. Thank you very much.
Yeah. Okay, thank you.
Doctor, any statistic that anyone recovered or they have served from this software or in any places or some sort of a statistic?
Sorry, I couldn't hear it clearly. Can you repeat it, please?
Did you apply these software in any places or in anything practically has been done anything?
No, at a practical level, we actually haven't deployed our models. So, but they are available on GitHub for any researcher to access and like use them mainly for research purposes. So we actually don't recommend like getting our models and deploying them in commercial settings, because there are actually limitations to these models. For example, like we still require some human supervision or some human intervention, especially if they are deployed in settings such as mental health interventions, because still these agents are artificial agents, and under ethical considerations in all of our papers, we discuss what are the ethical implications that can happen if we deploy such agents in a commercial setting without any human supervision, for example. So we highly recommend using our models only for research purposes at this point. And if you are deploying them in some setting, also to have some sort of human supervision when you are deploying these agents. So that's a very important consideration. Yeah.
Thank you, Doctor. Any other questions before we wind up? Okay, so on behalf of Institute of Engineers Sri Lanka, I would like to thank Dr. Anuradha for spending her precious time to deliver this lecture, wonderful lecture. And I would like to thank ISM President, Secretary, and the staff to arrange this session. Also, my colleagues who are in IT and Computer Engineering Committee members, I would like to thank them also. Thank you very much, Dr. Anuradha. Thank you. Thank you for being here with us today. Have a pleasant day.
Yeah.
Thank you. Thank you very much.
Thank you for the opportunity. Thank you very much.
Okay, thank you. Have a nice day.
Have a nice day. Goodbye.